With that, I would love to introduce our speakers for the day. We have Jamie Orlando, Director of Sales and Marketing at Butler Technologies, and Andrew Bombach, the Head of Wearables Research and Development and Production Manager at ACI Materials. A little bit of background on our speakers. Jamie spent over 20 years in R&D designing and producing products for international companies such as Rubbermaid and Draeger before joining Butler Technologies in 2017 as Head of Sales and Marketing. Andy enlisted in the Army out of high school and served as a paratrooper in the 82nd Airborne Division for 6 years. Following his Army career, he went to school for mechanical engineering before joining ACI Materials in 2017. With that, I'll pass it off to Jamie and Andy.
Thanks, Kelly. First, I just wanted to welcome everybody. Thank you for joining us today. We're going to cover a number of topics, just talking about the history of heated technology, kind of where it has been, where it's going, the advancements in inks and materials, substrates. But I wanted to tell you a little bit about me, about my background. Like Kelly had mentioned, spent a lot of time in research and development. I went to Penn State and got a couple of engineering degrees. So I grew up in Erie, Pennsylvania. And if you don't know anything about Erie, it is the snow belt of the Northeast United States. So every year, Erie competes to be the snowiest city in the United States. And every year it seems like they're up there on the top, usually competing with cities like Syracuse, New York, and Muskegon, Michigan. But growing up, there's a ton of snow, and you don't realize how much snow it gets until you actually move away from that area of the country. I didn't realize that 3 feet of snow over a weekend is really not common. So growing up in that environment, you do what most people from Erie do, is you learn to ski. So I grew up at a young age, skiing, spent a lot of time up at Peak and Peak in New York. Spent some time after my kids were born. I took a little bit of time off skiing, and when they were younger, we all started to ski together as a family. And you can see this is me and my wife and my 2 daughters, and we like to take pictures of us at the top of the mountains when we go out skiing. And it's kind of become a fun thing for us. But the picture on the left is actually us just about a month ago, and this was at Seven Springs here in Pennsylvania. The air temperature at the time was 8 degrees. And so with a 25-mile-an-hour headwind and going down the hill, it was like -3. That is cold. It is really cold. And so you feel it after every single run. We'd have to make a run, and we'd go inside and get warm after every run, and then you get back on the lift. And my daughter said to me, "Dad, 8 degrees, it's not that cold." And I said, well, snow freezes at 32 degrees. 8 degrees is cold. That's like the difference between it being 90 degrees in the summer and 66. Like, that's a big difference. And so, as we were skiing, we would use this tiny little hand warmers, right, to warm up our hands. And so that's the thing that gets cold on skiers, right? It's your hands, it's your feet. It's not necessarily your core. And so if anybody's had any experience either hunting or skiing, they know that, you've got these hand warmers, and they're not the ideal solution, but they're a solution. So you unzip this little bag, you take out these little sandbags, you shake them up, you put them into your gloves, and then your palms of your hands are really hot. But then as you're skiing, your fingers get extremely cold. So then you play this game. When you go down the run, you hop on the lift, and you immediately take your fingers out of the finger holes of the gloves, and you grab onto that sandbag tightly and hope that your fingers will get warm by the time you hit the top. And sometimes it works, sometimes it doesn't. But then you get to the top, and you got to put your fingers back into the finger holes, and it's like ice cubes. So it really doesn't work. And then, don't get me started on the sock warmers, because those things wad up at your toes. They don't really keep them warm. So it's not a great solution. What we're going to talk about today is actually going to be a very nice solution for this. As a skier, what you see on the market right now is heated apparel, and typically it's jackets, right? It's heating your core. Our technology is going to be really good for heating those extremities that you typically don't get with heated jackets. So I wanted to talk a little bit about what technology is out there right now. And what's prevalent on the market is your typical wired heaters. Like everybody has seen this. Everybody's probably had one around their house. Either their parents had it, their grandparents had it. And just looking at that image, you can feel the wires in it, right? It's kind of bulky, it's uncomfortable. You put it on your back, you can kind of feel it. You can feel hot spots and cold spots. It's not great. It works. Um, but the problem with that is, you've got fires that can happen, potential fires. Every year there's fires that occur with heated technology like this. There's burns and fatalities. And so I just wanted to cover kind of where we are and then why that isn't really a great solution when it comes to wearables and clothing. So you think about the wired up solution, and I mean, the first thing you think about is the kind of it's uncomfortable. You can feel those wires. You don't have great uniform heat. They tend to be heavy. And the main thing is they're really susceptible to water, right? So you can't take a heated jacket with wires in it and throw it in the wash and wash it. The other thing is you can't get it into socks and gloves because you've got a stick in the areas like the backs of your hands where you can feel it, and you can't get it down into your fingertips. And so we're going to cover kind of what the solution is now, what's on the market. So talking a little bit about the advancements. So we're going to get into material advancements. Andy's going to have a chance to talk with you a little bit about where we were and where we're going. I'll go back into kind of design considerations if you wanted to work with a company like Butler Technologies and ACI Materials. Our manufacturing process, and even what market applications are on the market right now and the readiness. So just to give you a little bit of a background, in 2014 is when your first, what we call stretchable inks really kind of hit the market, your first conductive stretchables. There were a few starts and stops with the technology. You didn't get a lot of people jumping on board real fast to adopt it. But in 2018, you had your first commercially available heated apparel using this technology hit the market. So over the last 5 years, we've been involved in a lot of development and a lot of testing of inks and substrates. We've worked closely with ACI and developing the best inks for this application. And I just wanted to make the comment now, it is market ready and commercially available. We've developed a solution that is able to be integrated into your garments and applications now, and I'm going to share that with you. So here we go. We've got what it is it's a complete solution. And what it is it's using a light, thin, stretchable thermoplastic urethane. It's a TPU. You're only talking mils thick, so it's ultra thin, and it can be integrated right into any type of garment. So you can be looking at denims, you can be looking at spandexes. So the great thing about this is it's extremely lightweight and you can't feel it. So if you think about those applications I was talking about in terms of gloves, in terms of socks, you can get really lightweight and get into some interesting areas, right, without having to feel wires. The other thing too is I want to be very clear. This is not on and most of the heaters on the market, when you talk about printed heaters, they started to come out and they're on polyester, and that's crinkly. It doesn't stretch. It doesn't feel great. This is a solution that is just ideal for garments. Um, the type of solutions we're talking about that ACI has developed is the TPU base, along with silver conductive inks and heater inks. And so what I'm going to do now is I'm going to turn it over to Andy, and he's going to tell you a little bit more about himself and a little bit more about the technology. Andy?
Awesome. Thank you, Jamie. And thank you everyone for joining us here today. For me, a lot of my memories of being cold were associated with the time I spent in the military. And the thing with that is, you tend to do a lot of stuff at night. So during the winter months, you're out there in the middle of nowhere, and it's pretty cold. And you really want to have the ability to stay warm without adding tons of bulky outerwear, because then you start to get a little inhibited in movement, and you're not always cold necessarily. You could be running somewhere, you could be marching to a location. So during that time, you're like, oh man, I got all this like bulky outerwear on, now I'm sweating like crazy. So having the ability to turn something on and off would be just amazing. Because one of the examples of where you're sitting in a spot for a really long time. When I spent some time in Iraq, I gunned a lot because I'm so tall. I didn't like sitting in the Humvees, but at night in the winter in the desert, it gets very cold. And I remember those days where I'm sitting there and your top half of your body is just totally exposed to the wind, and you're just getting so cold. Your hand starts to get like that sluggish feel. So being able to have something that, like Jamie said, that keeps your extremities warm, you're not going to sacrifice any like reaction time and things like that. And with soldiers and people in the military, they do love to have gear. So that's definitely one thing that I remember is people like getting custom gear and things like that. So for heaters, I could see that definitely being something soldiers would be interested in. So as Jamie had mentioned earlier, we at ACI, we've made some material advancements in this area when it comes to the inks and screen printing, or the screen printable inks that we make here. And the reason that we have an advantage is because of our patented cavitation process. So this is just a mixing process. And what it does is it gives us really tight control over the processing parameters that each product gets. So we get really uniform batch to batch consistency. And the way the cavitation process works is that instead of like traditional, the way like people make inks right now is they use a 3-roll mill, which is, most people are familiar with like a pasta maker, right? Just the rollers, you put the dough in and it comes out. So they're basically doing this with inks to mix them really well. And it's a little more, complicated than that, but that's kind of the general idea. Whereas, that is a fairly old technology, definitely well over 100 years. Roll mills in general have been used, throughout time. And, there was definitely a need to improve the process. And so the cavitation process is much more precise and much more controllable than something like a 3-roll mill. And all of these, the mixing advantage that we have gives us better mechanical strength in our products, increased stretchability when it comes to the wearable products, and then increased conductivity in general for the conductive coatings that we make here. And then the products in particular for the heater application are these 3 right here. And so the SC1109 is a 3rd generation stretchable conductive material. And this was, developed over, in general, our inks have been developed over time, and working with Butler has really helped us, narrow down how to get these to work and hit specifications that are needed for this type of or these types of products. And then the SC5025, that is a 2nd generation now, fixed resistance stretchable heater ink. And this is what you're using to print the area that heats up. And when it comes to the 5025, there's carbon materials in there. And so again, like the cavitation process really shines in something like carbon because of the way that it's difficult to mill that without damaging it or without completely, breaking it apart and mixing it, making a homogeneous solute or mixture. So the cavitation process with something that contains carbon, it just really makes a huge difference. Like there's not a comparable mixing system out there that can mix it like us. And then the SC3104 is the insulator ink, and that's just used to protect the circuit, the heater, the bus, and it doesn't diminish the stretchability of the circuit at all, and it increases the washability as well. So here is a picture of the fixed resistant heater. This was a demonstrator that we worked on a few years ago now. And this was, if you look at the picture on the left there, you can see the vertical bars on the outside. That's the SE 1109, and that is the conductor that carries your power to the heater coils, which are printed in the middle. And then off to the right there, where the two bus lines tail off, is where you're going to go and make a connection to the voltage source. So this is, this is something that is ready, like Jamie had mentioned, and totally can satisfy the application requirements to make heaters and garments, and have good life cycle. And here is a video of a heater being stretched while being viewed with a thermal camera. So we developed our own stretch machine so that we could stretch all kinds of different things, which is obviously important when you're developing an ink to do that. But here is a nice kind of visual demonstration of a heater being stretched to 20%, and it's being heated. And so this is just, kind of showing the capabilities, the stretchability, and the uniformity that you get in the heat while it's working. And then, as we develop these inks, we're working with Butler. We're basically, helping with whatever we can, but essentially they're the ones making these parts, and so they're getting all these inks and putting them into your guys' applications. So really great stuff. And then Jamie's gonna go over all the details of that right now. So I'm gonna hand it back over.
Great. Thanks, Andy.
Yeah.
What we have here is kind of a visual representation of that stack up that Andy was just showing you within the jacket, just so you know the kind of the process in creating and developing these heaters. I'm going to start from the bottom up, right? So you're going to have some type of fabric that you're going to be applying this to. And it starts with the base TPU film. We do everything here in a screen printing process. So we are screen printing these inks that ACI is producing onto the TPU. You're typically starting with your resistive elements, your heater elements, right? And then you apply your SE 1109, the bus bar system, over top of that. And then at the very top of that, you can either put the encapsulant ink, or you can put another layer of TPU over top of it if you wanted to do a completely watertight sandwiched design. And so, this is what we do. And then this gets laser cut out, and then it's actually hot melt. It's applied to any type of fabric. And so what you're going to see in this next image is just kind of an example of what the press process looks like. This is just a simple thing in-house, but these circuits can be put onto any type of fabric, and they bond using heat and pressure. So now what we're going to talk about a little bit about the design and customization. If you have an application and you came to us today, what is it that we would need to know in order to start your design? The main thing is, what are you putting this on, and how hot do you need it to get to, right? What are your requirements on heat? Not only just how hot do you need it, how long do you need it to run? And there's always a balance between your battery life, battery size, and runtime, and your heat requirement. Cooler temperatures can be run for a longer period of time. Hotter temperatures, obviously, you have to do that trade-off with battery life and size. So that's the main things that we look at. And then, where do you want to terminate? Where do you want voltage being applied to this? The great thing about this is, because of those buses, I mean, you can run bus up from like the toes of a sock up to, say, if it's a calf high, up to a point on your calf. So you can bring the power source completely up and out of a shoe. They don't need to be localized, right? And you don't need to run hard wires around your garments that somebody's going to feel. So that's kind of the gist of it. Everything's use case depending on the size of the heater. That's another thing. If you're trying to do a small patch on your arm versus a large swatch on your back, all of that is kind of that. We play into that, right? So we just need to know those requirements, and then we work with you in ACI to design the optimal application. So now I want to get into kind of what are the real benefits of this technology? I think the absolute biggest one, we've been talking about it so far throughout the webinar, is that it is stretchable. Your existing hard wires are not stretchable. Even some of the carbon fibers that you might see out of there, you're not going to get that stretchability and washability. So it really makes these applications ideal for thin base layers. So if you think about your kind of compression shirts, yoga pants, thin hiking pants, that's where this technology really shines. It's safe. It can be used in medical applications. So you think about different areas where you could use heat and warmth, and I'll talk a little bit more about that later. But the main thing is just think about the comfort and think about the comfort of the garments you're putting it into. So now I'm going to get into kind of additional applications and where you can use this. This technology is absolutely ready now. It gives you heat, and not only heat, but that range of motion, right? It's the freedom to be able to do things with it where you don't have to be confined by a hard wire. Think about hiking gear, hiking pants. Think about camping gear. You can put it on tents, clothing. You can put it on camping chairs. I mean, I'm sure everybody's had the experience of being camping where you're sitting on the chair and it's a really cold night and your front's really warm as you're facing the fire. Wouldn't it be nice to have something on the back of your chair that you can have that's thin, lightweight, and warms that as well? And here's another really cool advantage. So this picture here was it taken in Sweden in Glasskogen National Forest, and that little person there on the left is actually me. That was me hanging off of a 300-foot cliff. So I was over there in September of 2012, and it was in September, towards the latter half of September. So it was cool. I mean, you're pretty far north. And we got to the top of this cliff face, and we were going to rappel down it. And of course, the wind's whipping, and it's cold, and you're trying to get warm as you're up there, right? You're about to go down the side of this cliff, and you want to be safe, and you want to have good grip because you're rappelling down. And I can remember trying to go through these exercises to get my body warm, and I'm cold up top. And then as you start rappelling down the side of this thing, you start heating up fast, right? You're expending energy. And at this point, I'd love to just say, oh, peel off some layers, get cool again, but you can't. You're hanging from a rope off of the side of a cliff. The technology that we have is ideal because you can put it into a compression shirt, right? Which gives me that freedom to be able to grab and climb. But it also allows me to turn it off when I start to overheat. And that's the beauty of it. Other applications you can use this in are athletics. And this is really cool. I literally just added this slide a day ago. I was reading a book Wednesday night, and it's called Atomic Habits. And in there, they told this story of the British cycling team. And so the story was in the early 2000s, they were horrible. They couldn't win anything. They were never placing in the Olympics. They were always at the bottom in the Tour de France. And they got a new athletic coach, Dave Brailsford. And what he did was he looked at implementing some incremental improvements to get the team, high performing. And so what he did was he integrated heat into their workouts. He integrated heat and biometrics, and I'll talk about biometrics in a little bit. But so what he did was muscles operate at an optimal temperature. And so he wanted to make sure that when they practiced or competed, their muscles were at the peak temperature needed for high performance. And by implementing that, by 2012, the British team had won all these gold medals, and they won 5 of 6 Tour de France's. So I thought that was really cool, and I wanted to include it because when you think about athletics, those are the type of things you need to think about. Consider baseball players, spring ball, spring training, they come back up north, it's cold. If anybody's ever played baseball, you sit in a dugout, you're cold, you go up, you bat, and then you've got to sprint to first base. That's where you can pull a hammy. So having warmth on your legs and your muscles are actually a very good thing. Same goes for NFL players, training camps, kids, right? When you're training, that's typically when you're going to be most injured, is when you're starting up a season. So using warmth for athletics is good. You can also use it on the flip side of that, and that's recovery. and physical therapy. So one of the things that they do, if you've ever had physical therapy, is they typically will warm your muscles before you go out and work out, and then they ice them afterwards. So you can include these type of heaters in things like knee braces, bandages, wraps, ACE bandages, because it's stretchable and it's comfortable. You won't have all those hard wires. So that's another big application for this. Now, we also talked about biometrics. The same technology used for heaters, these inks, these silver inks that ACI is producing, can also be used to create biometric sensors. What that's doing is that's looking for feedback from muscles. And I mentioned that cycling team was also getting that type of feedback. Right. This is great for professional athletes that want to look at data. There's been studies showing that an athlete, if they use their quads and hamstrings in the right ratios when they jump, they get a higher jump. And so by using biometrics, you're able to kind of get that data and use it with, your performance and professional athletes to kind of, I guess, moneyball and become better. This same technology can be used for brainwaves in EEG applications, electrocardiograms, get your heart rate. And they can also not only sense electrical signals coming from muscles, but they can apply electrical signals to muscles. So you can do e-stim. And again, that's another thing that's really good with therapy. So imagine heat and e-stim at the same time, and you're talking about faster recovery times. So just in summary, just the benefits of this technology. There is an established market for this. Looking at some of the research, by 2015, they expect the heated jacket market to hit $300 million. That's just jackets alone. And of course, that's given the existing technology. With this new technology, there's such a broad market. And then the other thing too is, there are companies right now that are moving. They want to be first in the market with this technology. There are early adopters that will buy this just because of that comfort, right? It's the user experience. It is a unique value, right? The proposition to your customers are that it's thin, it's stretchable, it's lightweight, right? And it's easy for us to integrate this. We've been working with ACI for a while, working on a lot of heater projects. We've got some initial designs that we can implement right with your product right now. We can also take a look at your requirements and do quick tweaks to be able to get you to market fast. And so I just wanted to wrap up saying, we've done a lot of this front work, us and ACI, and we have the technical expertise and the personal support to be able to help you with any of the projects you have. So what I want to do now is just turn it back over to Kelly, and we'd like to answer some questions you might have.
So the first question that we get all the time is, what does the full development process of one of these heaters look like? So take the materials from ACI, Butler gets the materials, and then from prototyping to full-scale manufacturing, what does that process look like?
Yeah, sure, I can answer that. So there's different stages. Obviously, the first stage is kind of the exploratory. Let's get together. Let's get an NDA under wraps just so we can talk freely. And then we typically have a three-stage process, right? We will develop prototypes with you. Usually time period for that, it could be anywhere from 6 to 12 weeks, depending on, the type of design that we need to do. And then there's a verification and validation stage. We want to make sure that your heaters are performing correctly, they're up to temperatures, you're getting the right results out of them that you need. And then we can go right into production. Once design's locked down, we just need to schedule, and then we can go right into full-scale manufacturing. So you can go anywhere from hundreds of parts up to tens of thousands.
Great. And it looks like we do have a few questions now. So the first question is, are there any products commercially using this now?
We do have a few commercially, yes, there are some products. I want to be very careful not to say who it is, just because like I mentioned, we do have some early adopters that are now pushing, and this will be on the market this year. So we've already been in development with a couple of companies now, but I because of the NDA process, I have to kind of abstain with the names.
And then two questions are relatively similar. So are there any samples available for people that want to test this?
Yes, and we do have samples. We're in the process right now of printing out some sample kits and things like that. So if you have a need to be able to test this, it's going to get to whatever temperature we had originally designed it for. We're not going to be able to tweak it if you needed something that gets super hot. But if this is something that you want to get into your hands and just test out, yes, we can get samples to you.
Great. What kind of connectors are you seeing being used for the heaters to the battery?
I guess there's a number of different connectors, and I know I don't want to let the cat out of the bag, but we do. I know Andy's working on a few himself, some new additions. But typically, what we see is some type of compression, where you're basically taking and compressing a connector onto an open exposed area of silver, which that you can get back to your battery pack. We have the capability of doing things like ZIF connectors, any type of Nickomatic Berg type connectors at the end, something that's going to withstand the voltage of the heaters. Andy, I don't know if there's anything else that you've seen or you want to add.
Yeah, I would say, the mechanical, attachment is probably going to be the most successful. But I imagine, coming up with a kind of a generic one, but most companies out there are going to want their own custom, connector with their logo on it. So to a certain extent, it's going to be on the final product on what that wants to be. But yeah, we'll definitely have some examples coming out that will, at least get the ideas going on how people can make those connections.
How is temperature regulated and what is preventing thermal runaway?
I can answer that one.
Okay.
So in general, like if you just hook a battery up to it, it's gonna have, it's gonna reach a point where it is limited and it won't continue going up in heat. But we do recognize that we want to have further safety implementations. So the idea is to basically have your battery pack is going to be managing the power connection to the device. So it'll run it through and kind of check the health of the heater, and then it'll turn on from there. So you can also use different types of methods to control the duty cycle on the battery. If you want to have like a low, medium, high setting. Yeah. So, and I think, eventually it becomes something that's controlled from your phone. So, you can just open it up, turn it on and off, and, just be very convenient. That's how things typically are now. Very convenient.
Yeah, I think a lot of the existing products too have some type of thermal management or thermistor that they've incorporated into their own design. So if you wanted to shift over to say a printed heater, you can do it with that same thermistor in there, just regulating it the same way you did the old design. You just now added comfort instead.
Another question is a lot of people have experienced screen printed designs on clothing specifically cracking over time. So we're wondering if these materials have been tested for longevity through repeated use and cleaning cycles. And I actually want to make a comment on this one before Andy takes over on the ink question, but I just wanted to note that the jacket that Andy showed, that was a completed version that he mentioned was created a few years ago, is not using the same materials that he showed you as the new heater suite. So those new materials were actually just launched fully into the market within the end of 2021. So Andy, go ahead.
Yeah. So that's a good observation, and I think essentially that's why Jamie had mentioned earlier that there may have been like a false start at one point. Not every stretchable ink out on the market is going to have the capabilities that our ink has. So I've witnessed at trade shows, seeing the capabilities of other stretch inks, and you're absolutely right. There can be cracking issues. But we do test these, and like you saw in that video where the heater was on, that was being stretched 20%, and to kind of put in perspective, like that material, that fabric with spandex, and it can basically only stretch to 20 to 25%. So that's more of like I'm putting this on and I just kind of like stretched it out. And in normal use, it's probably not going to even see, you know, that amount of stretch. But we do take that into consideration. And then as far as washability goes, it is definitely washable, and it's good. And it's just like any piece of clothing, you know. If you have something that you want to last a long time, you just wash it in a certain way. But they are washable, and you can put them in the dryer as well. And a lot of these things are, you know, design considerations. What fabric do you want? Like how hardy do you want the material to be? If you're planning on just kind of telling people go ahead and wash and dry it, you know, you're gonna want to consider, you know, things in your design.
So is this material a premium over that's existing technology? If so, what would be the discrepancy between, for cost to the consumer, between existing technology to transitioning over?
Yeah, when you're talking about cost, it's hard to say. It's really dependent on the design, right? The size of this thing and what you're trying to replace. I don't think the cost difference is that great between the two. It's hard to know because I'm not buying in wired heaters. I know what I can produce one for. But let's just say if I was producing, say, an 8x10 heater and there was a wired one in the same spot, I'm willing to bet that the costs are going to be ballpark the same in volume. The more volume, obviously, the better. But you can produce something like that in under $10. I'm throwing out a wild number here. Just keep that in mind. When you're talking about the amount you could then charge for a premium heated jacket is way more than what that is. And that, again, that's a wild assumption because it's based on the amount of ink, the heater size, you know, how many you're ordering. If you're only ordering 100 a year, obviously you're not going to get the economies of scale if you're ordering 10,000 or even 100,000 per year. So it's case by case, but we're not talking about, oh, this is a factor of 10 times more expensive. It's not at all. Hopefully
Yeah.
that answered your question.
Yeah, and just the screen printing process too, you know, it definitely competes with the wired heaters and the carbon fiber heaters. It's just more scalable process. So
Yeah, it also depends where you manufacture. Obviously, Butler does all their manufacturing in their facility in Butler, Pennsylvania, in the United States. We often get the question from apparel companies if we can send products overseas to be integrated into their products there, and we definitely can do that. What is the temperature typically designed to for apparel?
It varies, but based on our experience, I think anywhere in that 120 to 130 F range is probably what you want for apparel. Anything less than that may feel a little too cool. Anything more than that, and it's just way too hot. You're trying to, you know, kind of fend off chill and provide warmth. So again, it really depends on where it's being used. But I think those are the main temperature ranges. Do you say the same thing, Andy?
yeah, right around like 120, a little over 120.
What is the typical resistivity of the ink used in the heating element?
The typical, so that information is available. We have our technical data sheets available. I believe those are on the website now. If not, they should be up shortly. I don't have that information off the top of my head. But I would say, you know, typically you kind of saw the examples of the heaters where you have all those coils going across. So you're typically going to want like a 3 to 6 ohm resistance across your parts, something like that. But yeah, if you want more technical details about the inks, I would encourage you to reach out to us so we can get you the TDS for them.
Yeah, I was going to suggest to anybody that's attending the webinar today, we can send an email out afterwards with a recording to the webinar and also links to the data sheets on ACI's site, and then a contact for us if you're interested in doing some development.
What do we think the market potential in dollars is of this technology?
Could you repeat that, Kelly?
The question is, what is the market potential in dollars of this technology?
I would have to do a little bit of research to know potential. I already kind of told you heated jackets was a 300 million, but then if you started throwing in heated camping gear, heated pants, socks, gloves, hats, that's going to increase exponentially. But the technology too, like I said, on the flip side, there's the whole biometric side of this, that these inks and substrates can also help. And so looking at market potential there in the medical space, it's pretty high, and I can't give you numbers. I don't know them off the top of my head.
Yeah, I can also add, as a print electronics as an industry is just growing rapidly itself. It was 9.9 billion in 2021, and is projected to get up to 23 billion just by 2026. So as you can see, just the technology in general, as it's becoming more mainstream, is definitely getting more popular. I know we mentioned the development process, and then we also mentioned getting these integrated into your garment. So what is the process to get a heater integrated into your garment?
Yeah, I think I laid that out with the time cycle. The process would be, number one, to get in touch with somebody from Butler Technologies, either Kelly, myself, or any one of our team.
Let me
And-
rephrase the question quick.
okay, go ahead.
So actual integration of taking the heater and putting it into your garment.
To take an existing design and just integrating it straight in, just so I understand.
Just what does it look like when we send the printed circuit to them? What do they do with it?
Oh, right. It's a heat press, right? So you do have to apply this with heat and pressure. And so a lot of your garment manufacturers already have that capability. They use them in things like seam tapes for clothing. So a lot of companies will already have that. If you're a software company looking to put something in, we may want to partner with an existing like cut and sew company that can do this. If you are a garment manufacturer, more than likely you do have those capabilities. So sorry, thanks for clarifying, Kelly.
Mhm. We got another question. Is there a way to repair a lead if it's torn within a garment?
A lead? You mean one of the power lines? Is what I'm assuming.
Yes.
Yeah, at this point, I don't know if there is a way. It all depends on the construction. Because go ahead, Andy, if you've got an answer.
Oh, I was gonna say, so typically like everything is encapsulated, right? So you don't have any more exposed, you know, conductor to attach to. So it would probably be pretty difficult, you know, I mean, maybe depending on, but I would say, you know, in general, no, you would want to basically replace that heater itself.
Okay. And another question that we often get is, can these go in the washer or dryer, or what is the washability standard for this?
We are, because this is if you will, a brand new market, right? We're moving into uncharted waters, if you will. We are in the process of working with some fabric manufacturers right now on creating washability standards. So we've already gone through a number of tests on this. Like Andy had said, throwing it through different wash and dry cycles, high heat, high temperature, high, detergents versus kind of a delicate cycle and a tumble dry. And so we're going through the process right now. So we're doing all that legwork in advance before we, jump in with other companies to know what is the optimal washability for your garment for specific fabrics, because it varies from fabric to fabric. To be honest, I mean, we're up to, dozens and dozens of wash cycles and still being able to perform.
Yeah, I mean that sums it up really well. You know, there a lot of variation on how people wash clothes, so there's a lot of investigating to do. But there are ways to do it, and you know, maintain a good amount of life. Like Jamie was saying, you know, I have one that I've washed a couple dozen times now, and it still heats up really nicely. And performs the way I would expect it to.
Great. We got another question about batteries. What batteries are we typically seeing being used, and are there any special batteries that are ultra thin or light for specifically wearables?
For the most part, I would say we're using some type of lithium-ion battery. They typically have a good current, the ability to have higher currents, and then also a good amount of battery life. But I wouldn't say we're at ACI. Definitely, we're not experts on what batteries to use or streamlining that and designing a battery pack. But for the most part, we design ours with the lithium-ion batteries.
Yeah, part of it is that trade-off that we talked about earlier too, about runtime and power consumption. So, I mean, if you want to get something very low profile and you're just heating a small area, say fingertips, you can get away with a much thinner battery, a lot more comfortable, a lot more ergonomic.
Great. Yeah, there's a lot of innovation going on with batteries as well. As print electronics are gaining momentum, there's a lot of different companies working on those types of battery solutions. What voltage are you running these heaters at?
The typical, I mean, we're kind of in the lithium ion cells. So you can run this from 1 to 3 cells. So 3.7 volts to 11.2 volts or whatever it is. So I would say that's pretty the voltage range. Even even those 5-volt battery packs that most people have for like charging your phone and stuff like that, you can run heaters off that as well.
Have you made comparisons for existing wired heaters and your printed heaters relative with topics such as washability and repairs? Basically just asking if we've made comparisons directly from a wired heater to the printed heater in regards to washability, repairs, performance.
Well, obviously, from a performance standpoint, we've got, I mentioned there's a few companies right now that are converting technology, right? So from a performance standpoint, we match up. And as I said, with some of your wired applications, there is no washability. There's no repair. And so like garments like that, you basically wear it until it's dirty and you can't wear it anymore. So yeah, I mean, this is definitely a viable technology if you're looking at some major clothing companies looking to convert existing to this technology. And like I said, it's the value prop. It's really the comfort and the lightweight that's the value of this technology. Okay.
I have 2 more questions here.
All right.
Do we think that batteries will last longer in a wired heater or a printed heater?
It's
all about power consumption.
Right. Yeah. So yeah, it really depends. Like the size of the heater. I would say in general, if you're looking at getting into that 120 degree Fahrenheit range, you're going to be running from 2 to 2.5 amps. So you can kind of have an idea of where that would have you end up. But on small heaters, you're running out very low. It's all about surface area coverage and how much power is going into the circuit.
So do we need any? Oh, sorry, Jamie.
Oh no, the one thing I was going to mention is too that the one thing about the printed heaters too is you can heat a more uniform area of coverage than you can with a wired heater, right? So to effectively get that warmth across a swatch with a wire, you've got to get hotter to be able to get those cold sections. Where in the printed heater world, you can get a more uniform heat distribution across that same area.
So do we need an additional layer for uniform heat dissipation, and what is the maximum temperature we can go to with printed electronics?
Obviously, if you add layers, it creates more heat dissipation. So we've noticed that going from no covers to a cover to putting a piece of fabric over top of it, right? It's just thermal conductivity at that point. The second part of that question, could you?
Yeah, what is the maximum temperature we can go to?
Andy, maybe you can answer that one.
That's a kind of a use case deal, but depending on the fabric and what type of construction you're looking at, we have heaters that go up into the 140 to 150 range. And yeah, that's basically off the same like battery, that we were talking about earlier. It's just modifying again your surface area to power ratio.
Great. What type of connector do you have to connector the printed 2D to powering cable 3D for comfort, reliability, and to avoid hotspots?
Okay, I guess I can try to jump in and answer this one. So you're saying for reliability to go from the 2D print to a 3D battery pack. There's a number, I mentioned a number of different connectors that we've done in the past to be able to get to that point. Obviously, depending on the amount of power that you're putting in there, you want to make sure that you're designed properly. So I would say that would be something that would be case by case. We'd probably want to look at something. In one case, one customer, we did a custom molded kind of clamp that sat over top of the end connectors. That way you've got a nice, thin, smooth, low profile way of getting right back to your battery pack.
Great. And we have one more question. The question is, what kind of investment have you made in each other's companies? I'm going to rephrase that to what does the relationship between ACI and Butler look like?
There's no monetary investment between our two companies. We're just very symbiotic in that we need inks. We need a reliable source of really high quality inks and substrates, and that's where ACI comes in. So we can't do what we do without them. And then through us, they sell their inks and materials. So that's it. It's really just a very good partnership and very symbiotic.
Yeah.
Yeah, another advantage of the partnership is with ACI being smaller than a lot of the typical ink materials companies that are used in this space. They can iterate quite quickly, so we're able to get really far on projects such as this fixed resistance project that we've been working on much faster than the typical development cycle.
Yeah, and that's really been kind of the beauty of working with ACI is just saying, hey, we've got this application, let's try something, right? And getting it done fast. It's all about design and iteration, and now quickly you can fail and get better and produce higher quality products. So
Yeah,
yeah, if that
definitely.
answers the question.
Yeah, I agree. I mean, it's a great relationship, being able to have that the open table between us and Butler, being able to discuss and come up to solutions faster. It's just a total advantage that we definitely want to take advantage of.
Great. And the last question that I see is, can this presentation be shared?
Yes, it's going to be online. Our team has it recorded, and we are going to be uploading this thing here within the week. So everybody, when we send out a thank you email, you'll see a link to the presentation, so you can go back and watch it.
Great. Yeah, like Jamie mentioned, we'll send out the presentation and we'll include in there the relevant data sheets to the ACI materials that have been mentioned, as well as contact information for the relevant parties at both ACI and Butler if anyone needs to reach out. I know there were a few questions about samples, so we're happy to have conversations with anyone who's ready to get rolling.
Well, I personally just wanted to thank everybody for attending. I appreciate your time this afternoon. Have any questions, feel free to reach out to myself, Kelly, or Andy. We'd be happy to talk with you.
Yeah, thank you so much for attending, everyone.
Thanks, everyone. Have a great rest of your day.